Now we look at graphing a sine function that has transformations also. So the problem we're interested in is this guy. Graph exactly 2 cycles. And we have 3 plus 1/2 times the sine of pi times the quantity x minus 1/3. It's about as complex as they get. So what we're going to do is we're going to make this look a little nicer so it kind of matches what we expect when it comes to transformations. So this is the same as, we're going to take this plus 3 and move it on to the end. So it's going to be 1/2 times the sine. And because this is multiplication, pi times x minus 1/3, all of this is the argument to the trig function sine, or the angle for the trig function sine. So one thing we can do maybe to help ourselves out to kind of see that better is maybe distribute our pi so that it looks like pi x minus pi over 3. Okay, so this stuff here is the same as all of this. And then all that remains is the plus 3, and so we'll put that on the end here. And so what we can see then is that the 1/2 and the multiplication by 1/2 and the plus 3 are y transformations. Okay, so we'll kind of deal with those. And then our angle is pi x minus pi over 3. The input to the trig function is what I'm calling the angle. It's also called the argument. Okay, so here's how we start. We start with the parent function, which is y equals the sine of x. And we're going to focus just on the y stuff. So the sine of x function sort of starts here at 0, ends at 0, and is 0 in the middle. Then halfway between those, at the quarters, if you want to call them that, at the quarters we go up here to positive 1, and down here to negative 1. Okay, so the sine parent function, one cycle looks like that. Now, the y transformations are multiply y by 1/2. So what that does is if I multiply my y values by 1/2, 0 times 1/2, basically I need to multiply each of these times 1/2, times 1/2, times 1/2. So now they're 1/2, 0, and negative 1/2. And then I need to add 3, which is going to shift everything up by 3. So what I have after I apply my y transformations, my new average value is 0 times 1/2 is 0 plus 3. So my new average value is 3. It starts and ends at the average value, and in the middle is at the average value. The quarters are the peak and valley of the sine function. So my new peak is 1 times 1/2 is 1/2, plus 3 is 3.5. Well, I guess we could write that as 3.5. You could also write it as 7 over 2. So that's my new peak. So this will be my highest point. And my lowest point will be negative 1 times 1/2, which is negative 1/2, plus 3, which is 2.5, or 5/2. Okay? And that's our third quarter here. So this is what we have after the y transformations. So now the key is we have to figure out the x values, the x transformations, like where do my x values match up for the beginning and the ending of this cycle. So the way to determine that, so this is the shape of our function right here. And in fact, that's the shape of our function from 2.5 to 3.5 on the y-axis, okay? We just have to figure out where it's located in relation to the x-axis. So the way we do that is a sine cycle starts with when the angle pi x minus pi over 3 equals 0. This is our start. Okay? And it ends when, for sine, whenever that angle equals 2 pi. And then I'm going to solve each of these for x. So here I'll add my pi over 3. And I'll divide both sides by pi, or if you like, multiply both sides by 1 over pi. Might be easier to see what happens then. 1 over pi times pi is 1, so we just get x. And over here, pi divided by pi is 1, so we just get 1/3. So this cycle is going to start whenever x is 1/3. Similarly, let's solve where it ends. If I add pi over 3 to 2 pi, well, 2 pi is the same thing as 6 pi over 3. And if I add 1 pi over 3, then I get 7 pi over 3 on the right side when I add my pi over 3. So I've got pi x equals 7 pi over 3. Divide both sides by pi or multiply by 1 over pi, and we get x equals 7/3. So our cycle starts when x is 1/3 and ends when x is 7/3. So now I need to set up my grid. So let me turn on my graph paper. Okay, so there we go. And let's see if we can put together all of this information: the start of a cycle, the end of the cycle, and the shape of the cycle. So I need to set up my x-axis, and since I'm starting at a third and ending at 7/3, I might set up intervals of thirds, 1/3. Okay, so let's set that up. So let's see here. We'll use, sorry, the screen's jumping around there. This will be my y-axis. And since my y values go from 2.5 to 3.5, I might set up my y intervals. In halves, 0.5s, okay? So that means my x-axis needs to be pretty low here. So we'll say that this down here is the x-axis, and I want to set up my x-axis in intervals of thirds. So I'll call this 1/3, then 2/3, 3/3, 4/3, 5/3, 6/3, and 7/3. Those are the two ones I'm interested in. Then I'll set up my y-axis in intervals of halves. So this will be 1/2, 2 halves, 3 halves, 4 halves. 5 halves was my low point, and 7 halves was my high point. So 1/2, 2 halves, 3, 4, 5 halves is here. That's the bottom of my graph. 6 halves, 7 halves. That's the top of my graph. So I know that my cycle is going to be within this band between 5 halves and 7 halves on the y-axis, and it's going to be in this band on my x-axis between 1/3 and 7/3. So what I'm looking at is putting my shape within this box here to match the shape that I had up here. Okay, so I need to graph a sine function in this new box. So the average value is right here at 3, right? This is 3, 6 halves is 3. And then the end of the cycle at 7/3 is the same average value. The middle is the same average value. So where's the middle? Well, I have 1, 2, 3, 4, 5, 6 intervals in this cycle. So the middle will be my third interval right here. And then the quarters will be at 1.5 grid marks. So there's a quarter and there's a quarter, okay? At the first quarter, I'm at a peak of the graph, and at the third quarter, I'm at the valley or the bottom of the graph. So this is one cycle of this sine function, right? It's the shape that we had from up here put in the correct place on the x and y axis in the grid. Okay, going from x equals 1/3 to x equals 7/3. Now, while we're here, we might as well state a couple things. For example, the period is how long this interval is. Well, I'm going from 1/3 to 7/3, which is literally 1, 2, 3, 4, 5, 6 thirds, which reduces just down to 2. So the period here is 2. The amplitude is the distance from my average value to the peak or the valley, so that's that distance, which is a half. So from 6 halves to 7 halves, the amplitude is 1/2. Okay? And of course, the average value, we already said, is 3. So the average value is 3, just to state some things about this function. Now let's go back, and the instructions told us to graph exactly 2 cycles. So what I need to do now is repeat this picture. Okay, so I have to measure the same thing either to the right of what I have here or to the left. So since my graph has more room to the left, I'll go to the left. And I need to measure 6 intervals for an entire period. So here's 1, 2, 3, 4, 5, 6 intervals. So I need to go back to this point here, and then my second green highlighted box, I'll draw exactly the same picture I did in my first. So the end of the cycle in the first green box is at 3, so the beginning has to be at 3, and the middle has to be at 3 because it's a sine function. Now the first quarter is going to be at the top, and the second quarter, which is right here, is going to be at the bottom. And I know it's overlapping with my labels, but it shouldn't be too bad at this point. And then I just repeat the same shape. I'm kind of trying not to cross through my numbers there. Now that's exactly 2 cycles of this function. I could have done the same thing with 6 intervals to the right if I wanted to. And I should be able to graph as many cycles as I'm told. But there are 2 complete cycles of this sine function.